A supernova, a cataclysmic event that causes concern among scientists and the general public alike, is among the most powerful and awe-inspiring phenomena in the cosmos. Among the most watched stars on the verge of such an event is Betelgeuse, a prominent figure in the constellation Orion. Betelgeuse has gained some of its brightness after a notable dimming period, but it now appears to be transitioning to a less active phase. This shift in behavior has led scientists to express growing concern about the possible outcome of Betelgeuse's life. There is ongoing debate about whether its eventual explosion as a supernova could affect Earth in any meaningful way. Orion, one of the most recognizable constellations in the night sky, is known for its two main stars, Rigel and Betelgeuse. Betelgeuse, also referred to as Alpha Orionis, is not just the brightest star in Orion, but also the larger of the two. The data collected by NASA's Hubble Space Telescope and other observatories suggests that Betelgeuse underwent a massive mass ejection event in 2019. This behavior was unprecedented in a star of its type. While coronal mass ejections are relatively common in our own Sun, the event observed on Betelgeuse is considered unique and has aroused intense interest among astronomers worldwide. What especially surprised scientists was the scale of this coronal mass ejection from Betelgeuse. The star ejected an amount of mass 400 billion times greater than the average coronal mass ejection, CME, typically seen from the Sun. This colossal cloud of hot gas released by the star temporarily covered some of its light, leading to the unusual dimming that was observed by both professional and amateur astronomers across the globe. Although some estimates place Betelgeuse farther away from Earth, there are models and observations that suggest it could be as close as 724 light-years. Determining the precise distance of red supergiant stars like Betelgeuse remains a substantial challenge in astronomy due to their immense size, variability, and other peculiar characteristics. Betelgeuse remains one of the brightest stars visible in the night sky. It is approximately 100,000 times more luminous than the Sun. However, this intense luminosity comes at a cost. The immense energy output of Betelgeuse means it is rapidly depleting its nuclear fuel, which hastens the end of its stellar life. Eventually, Betelgeuse will exhaust its fuel supply and disintegrate under the weight of its own mass. This dramatic collapse may result in a supernova, and depending on the outcome of that explosion, Betelgeuse could leave behind a neutron star, or, if conditions are right, perhaps even a black hole, if our current theories of stellar evolution hold true. This naturally leads to a deeply compelling question. Does Betelgeuse pose a threat to Earth? A supernova outburst occurring just a few tens of light-years away from our planet could have devastating consequences. When a supernova explodes, it can generate a level of brightness equal to that of an entire galaxy. This means that even if the star is relatively close, such as Alpha Centauri, its effects could not be ignored. Interestingly, since the year 1604, humanity has not witnessed a supernova within our own galaxy. The most notable recent event was in 1987 when a supernova was observed in the Large Magellanic Cloud, a satellite galaxy of the Milky Way. This supernova occurred at a distance of about 169,000 light-years. While it produced remarkable visual effects, it did not pose any direct risk to Earth. Nevertheless, the concept of a danger zone around a typical supernova remains highly relevant and deeply intriguing. If such an explosion were to occur in our cosmic neighborhood, it could have severe implications for life on Earth. It is important to note, however, that in cosmic terms, nearby supernovae are considered relatively minor compared to gamma-ray bursts, which operate on a completely different scale and are far more powerful. Supernovae are bad news. They possess the destructive potential to annihilate biospheres, disrupt planetary atmospheres, and flood entire worlds with lethal radiation. One major concern relates to a planet's ozone layer. Certain types of supernovae can destroy a planet's ozone layer years after the initial explosion. A recent study has added to this concern by revealing a new potential danger. When giant stars explode as supernovae, they can briefly reach some of the highest luminosities in the entire universe. These immense explosions can outshine hundreds of billions of other stars combined. A single supernova can eclipse the brilliance of an entire galaxy. So, will Earth be destroyed by a Betelgeuse supernova? When the star explodes, it will become the second brightest object in the sky after the Sun. Despite being far from Earth, Betelgeuse, when it goes supernova, will shine brighter than the full moon and will even be visible during the day. Its brilliance will be so intense for several weeks at the peak of the explosion that it will cast shadows in the middle of the night. Despite this terrifying brilliance, the visible light from a supernova represents only a small fraction of its total energy output. What's far more concerning is the high-energy radiation released during a supernova. This radiation typically takes the form of X-rays and gamma rays. These high-energy emissions are capable of catalyzing chemical reactions that remove oxygen from the ozone layer that protects Earth. Without this critical shield, life on Earth's surface would be directly exposed to the sun's ultraviolet radiation, potentially triggering an extinction event. In the first few seconds after the initial outburst of a supernova, the primary threat is the radiation burst. However, a greater danger looms over time. Eventually, hundreds or even millions of years later, cosmic rays, subatomic particles accelerated to near the speed of light, begin to emerge from the remnants of the explosion. These cosmic rays can further damage the ozone layer and blanket a planet's surface with dangerous radiation. In addition to carrying a significant portion of the supernova's total energy, these particles pose a long-term threat to planetary biospheres. In fact, there is growing evidence that such events may have occurred in Earth's distant past. Significant levels of iron-60, a radioactive isotope of iron produced in supernovae, have been found in the ocean floor and lunar regolith. According to scientific analyses, the presence of iron-60 indicates that Earth was likely hit by supernova ejecta within the last few million years. This adds another layer of complexity to our understanding of life on Earth and the role cosmic events may have played in shaping its history.